All right, welcome, ladies and gentlemen, to this class. I want to look briefly at the area and slope of both the velocity time graph, the displacement time graph, and the acceleration time graph. Because these are some of the questions they ask in objective in WAEC and JAM. But some of you don't know how to get it. You just guess at the end of the day. When they are asking that, what is the slope of the velocity time graph? What they just expect you to know is this. Now, first, let's say we are plotting this time around. I'm looking at the displacement time graph. Displacement time graph. If I plot displacement against the time, displacement unit is meter, while the time unit is second. Now, if I plot displacement against the time, what I have is displacement time graph. Displacement time graph. And so, what happens? What is the area and the slope of this displacement time graph? Is what we want to look at briefly. Now, when you plot the displacement against the time graph, you have a straight line graph like this. Now, when you have a straight line graph, now you get the slope. You get the slope. Now, when you get the slope here like this now, we now look at the slope of this graph. If you look at the slope, if you take here now, here is your G2, here is your G1, but we are interested with the unit. Now, here is your T2 and here is your T1. Now, slope is usually increase in the displacement over increase in time. Now, the displacement, now the unit for displacement is meter, while the unit for time is second. So at the end of the day, what you are now having is meter per second. So the quantity that gives you meter per second in physics is velocity. So if they ask you that what is the slope of a displacement time graph, your answer is velocity. Take note of that. Because the unit for velocity is meter per second. And that is what we just calculated. That is what we just calculated. So once you are asked that what is the unit of, what is the slope of a displacement time graph, you say the answer is velocity. Okay, but if they ask that what is the slope of distance time graph, in the case of distance now, here will be distance, not displacement. But every other thing will remain. The unit will remain. In that case, what you'll be having is not velocity, but it's going to be slope. It's going to be speed. So take note of that, because speed and distance, they are together. Displacement and velocity, they are together because they belong to what? Vector quantity. While distance and speed belong to scalar quantity. So if they ask you that what is the slope of a distance time graph, please, the answer is speed. Don't use velocity, even though they have the same unit. But if they ask what is the slope of a displacement time graph, your answer is velocity. Don't go and use speed, please. Take note of that. All right. Now let us now look at the area of this same displacement time graph. The area, now we have a shape of a rectangle. We have a shape of a rectangle. I want that area of a rectangle is length times breadth. And in this case here now, the length is the displacement, which is meter, times the breadth, which is time. So meter second. And in physics, there is no quantity that is meter second, which means the displacement time graph and both the distance time graph don't have area. What they have is only slope. The slope for displacement time graph is velocity. The slope for this distance time graph is speed. So that is it for the displacement time graph. So let us now look at the velocity time graph. In the case of velocity time graph, we are using velocity. The unit for velocity is meter per second, while the unit for time is second. The unit for time is second. Now, when you still plot again, you have a straight line. You have a straight line graph. So when you try to get the slope, Slope is usually increase in y over increase in s, which means the y-axis is v. That is the slope. This is velocity time graph. Velocity time graph. Okay? Velocity time graph. The slope is increase in v over increase in time. Now, the unit for velocity, as you know, is meter per second divided by unit for time, which is second. Now, when you work this is as meter per second divided by second, which means if you work this one, this will give you second square. That means times 1 over second. That's what you have in there, which is as meter per second square. Meter per second square. So that goes to show that the slope of a velocity time graph is going to give you the quantity that gives you the unit. And the quantity that gives you this unit is acceleration. So when they ask that what is the slope of a velocity time graph, say it is acceleration. Don't forget it. The quantity, the slope of a velocity time graph is acceleration. Okay, now let us now look at the area. The area again, this time around, the area again is still shape of a rectangle. Shape of a rectangle. If you work the shape of the rectangle, area of a rectangle, we know that it's length times breadth. Area of a rectangle is length times breadth, and the length is meter per second, times the breadth, which is the unit of the time, which is second. So second will not cancel second, you now have meter. It means that the area of a velocity time graph, which quantity that gives you meter, is displacement, not distance, because velocity and displacement, they go together. Don't say distance. We know that distance has unit of meter, and displacement also has the unit of meter. But if they are asking for velocity time graph and you see a unit of meter, so the quantity that will give you this meter is not distance but displacement. So when they now ask that, what is the area of a velocity time graph? Your answer is what? Is displacement, not distance. Please take note of that. So the area of a velocity time graph is displacement, while the slope is acceleration. Is that clear? All right. So let's look at the last one. The last one is acceleration. Acceleration time graph. Acceleration time graph. Okay, that is plotting acceleration against time. And we know that the unit for acceleration is meter per second square. You have to know those units. Then the unit of time is second. The unit of time is second. All right, again, when we plot the graph, we still have a straight line. Let's get the slope now. The slope. Now, the slope, as we know, increase in A, increase in acceleration over increase in what? Increase in time. Acceleration is meter per second square. Then divided by second. When you work this will give you meter per second cube. So which quantity that give us meter per second cube? He said meter per second cube has a quantity, and the quantity is called joule. Call it joule or joule. Joule or joule is the quantity. The unit of joule or joule is meter per second cube. So the slope of acceleration time graph is called joule or joule. Joule or joule. So this is the slope of acceleration time graph, joule or joules. So please take note of that. So let us now look at um, the area, the area.